So the next person that we'll be joined by today is Nick Voulvoulis, who's Professor of Environmental Technology and also the Deputy Director for the Centre of Environmental Policy at Imperial College London. Now, Nick's research spans a huge range of different topics and areas, but with a particular focus on systems thinking and how human and environmental systems can interact. We're delighted that he could join us today, so please welcome Nick to the stage.
Okay, so thank you for inviting me. And I mainly teach at Imperial. I do my research is on the interface between science and technology, addressing sustainability issues. So I'll kind of treat you like students in the next kind of 20 minutes. Most of the kind of world, the crisis we face in the world, they normally refer to two different types. One has to do with the physical scarcity of water. This is really when the availability is not enough to meet the demand. So it has to do both with the geography of the different areas, but also kind of the demand in terms of the population needs in terms of water. The second one is mainly focusing on drinking water. This is mainly in poor countries. And this is when the infrastructure is not there or people cannot have access to even available drinking water supplies just because of their level of development. And you can see some examples in terms of where these problems take place. Of course, there are some places that both of these crises take place at the same time. When we refer to renewable, when we refer to availability of water, we really refer to what we call renewable internal freshwater resources. And this is the flow of water that comes from precipitation, from the rain, and it replenishes aquifers, it replenishes rivers, and this is the available water we have to address our needs. So you can see that globally, this availability per capita has been reducing with time. So this is a challenge that we face across the globe in terms of water available to meet our demand. The second one is really this idea of availability to demand as a difference between the fresh waters we have available and the demand in terms of how much we consume. And here you can see, like before, countries that mainly are in areas that there is not enough precipitation, enough rain, to suffer from available water, and therefore do not have enough to meet their water needs. This is a different one. This is where you see the Sustainable Development Goal 6, which is about access to drinking water supplies. So access within 30 minutes of going and coming back from a safe source of water. And you can see here that mainly the countries that are suffering from this are the poor countries in the world, when people have to walk to get access to find a safe drinking water source. So this is the second type of crisis we talked about. Now, the second type of crisis, really this idea of water for household needs, it's not so much, although we think it's related to availability, it mainly comes down to institutional and political choices. Is a result of lack of infrastructure, it's a result of poverty. So it's not so much to mix it with the first type of crisis. These are crises that are not really acceptable anymore on the planet. Household water needs account for a mere 10% of our total water needs. So this is countries that for that 10% do not have access to have safe drinking water for their peoples. And again, this is something that is directly reflected to the Sustainable Development Goals, and this is investment required to help these countries provide the infrastructure to at least have household drinking water available to their population. So if we combine these two crises, we come up with the idea of water scarcity, which is really the availability when we have physically shortage of water resources, and also the lack of access as a failure of institutions to ensure that there is adequate drinking water supply for the population. And this is mainly come as a result of demand. We know population is increasing globally. We know the urbanization, more people move to urban centers. And we know that consumption with development is unfortunately also increasing, so we need more water per person. At the same time, availability, groundwater is overexploited in most places around the world. Surface water is getting polluted. Therefore, it's reduced, its availability for drinking water purposes without treatment is getting reduced. And we know that a lot of rainfall, we've seen some examples earlier, is not really collected properly to be used for as a source of drinking water. This affects our industry and our food. We'll see in a second of how our water needs are distributed across those sectors. And at the same time, it's putting at risk energy security, food security, and of course, kind of human health. Environmental impacts, as we are trying to address our needs, we overexploit water resources, we pollute by our industry and other activities water resources and create water quality deterioration. Climate change comes to affect all of that, and of course, the main parameter here is also access in terms of poverty and in terms of you cannot really address water issues without addressing general issues of poverty in some countries that suffer from this. So we normally see, I'm going to take you through a series of crises and see kind of why these are taking place. We often see now London is one of the cities in the world that is predicted to face a water crisis in the next years. It currently loses a lot of the water from its network during leakage in pipes, and Thames Water is suffering. It has the greatest kind of leakage rate in the country. And to start with, let's see kind of how we use our water. So about, this is in England, and about 5,000 billion tons, cubic meters of water are extracted, are used in England. We use about 140 liters per person per day if you live in London. During the pandemic, that went up, so that was 175 liters per day. I guess people were having more showers during the pandemic, but that's kind of what the data shows. And actually, the amount of water is lost in the leaks is about 187 liters per day per household. So you might use 140 per person, but 180 liters per day per household is lost in our pipes. You can see on the right the amount, kind of how these 140 liters per day are distributed in terms of having a bath or going to the toilet. But you can see that's kind of the normal direct use of water in terms of municipal needs. If you look at now the greater use of water behind our consumer lives, that's a very small amount in terms of this direct usage is about 140 liters to 150 liters per day, but actually most of it is consumed in the food we eat and the energy we consume. So taking into account that, if you wanted to save water, you might turn the lights off in some respects. Right? But the total amount of water we use is 4,645 liters per day. And most of it, actually, of that comes from outside the UK. So only 38% of that water is actually from the UK. Most of it is embedded in the products and the food we eat from different places of the planet. So this is where I'm at. This is your first test. I want you to try and identify. This is a satellite picture of a place in 1974, the same place in 2000. And the task is to, if you have an idea where this is on the planet. I have one hand up. Yep.
It's somewhere in southern Spain. I can't remember the name of the town, but...
Yes, it's in southern Spain. It's true, and sometimes people will say that Spain is it has a lot of tourism. This could be houses. They are not. This is how it looks today. You can see it here from a satellite picture. So it's not houses. What is it? Greenhouses. So this is greenhouses. This is This is Almeria in Spain, which is Europe's vegetable garden. Most of Europe's current production of food and vegetables comes from this area, including in the UK. This produces food of about 2 billion euros in terms of value in 40,000 hectares of greenhouses that have actually kind of incentivize the production, but use a lot of water. Again, this is in the middle of the desert. It used to be a desert. And in this sea of plastic, you can see that all the aquifers have been overexploited, right? And as a result, Almeria now has 4 desalination plants when we desalinate water to irrigate, right? So in that, and you can think of the energy consumption behind that, but also in some funny way, it has turned us into Almeria into a very now water efficient production of water because water is so expensive to take it from desalination. They have changed their systems to become very efficient in how much water they use. But you don't have to run out of your water to do that. You can do that much earlier without having to build a desalination plant, clearly. Okay, so when you think about solutions, we go into the area of main thing about kind of saving water and also about reducing pollution. What we increasingly need is more integrated solutions, and this is where the idea of closing the loop, of the idea of water reuse comes. So traditionally, as a society, we take water from the environment, we treat it for drinking water purposes, we distribute it, we use it, and then we collect it as wastewater before it goes down the wastewater treatment plants and then back to the environment after we clean it. Increasingly, we need to use advanced treatment options to clean water for drinking water. We have pharmaceuticals, we have pesticides, endocrine disruptors in our raw water, so we have to make it safe, and at the same time, we have to do the same thing, even using desalination technologies to make it again safe to return it back to the environment. So we're paying almost for this process twice, once for drinking and one for putting it back into the environment, which when you realize that actually the water we clean after wastewater treatment is almost cleaner than the water we put it in, and the fact that wastewater treatment is more expensive than drinking water treatment, it makes sense to kind of close the loop. And this is the idea of not putting the water back to the environment, but cleaning it once to high standards, higher than drinking water standards, and supplying it as drinking water to consumers. So that is a more sustainable way of looking at this. It is tap water, I think. We'll come back to that in a sec. So look at that's what happens in Berlin. In Berlin, which doesn't have enough rainfall to replenish its aquifers, the wastewater is cleaned to high standards. It's put into lakes where artificially it recharges aquifers, and then the water is abstracted without any disinfection and is used as drinking water to meet the needs of the 3.4 million people that live in Berlin. So this is almost a direct reuse of water because you have it cleaned as wastewater, just back in the aquifers, and then you don't even disinfect it, which we would have done normally because it's so clean. So this is a kind of a case of direct reuse. And you think, okay, they don't have enough water in Berlin, maybe that's why they do it. Actually, London gets less water than Berlin. It gets significantly, the idea of rainy London, it's a bit of a myth. It doesn't rain as much as people think. And actually, London is in a list of cities that will suffer from water availability, is running out of water in the future. But it's not a place that you would expect your needs to be produced, to be addressed by desalination plant. So how many of you knew that the water in London comes partly from a desalination plant? We have built a desalination plant here. So this happened in 2010. Britain's first desalination plant was constructed in 2010 at a cost of £270 million. This is because when Ofwat in the middle 2000s asked Thames Water to provide additional water for 150 million liters per day to address the lack of water, mainly in the summer months when the demand is really high, it was cheaper to actually provide the desalination plant than to fix the leaks. Because at that point, Thames Water was losing 500 million liters per day in its network, a 30% reduction of which would have delivered the water that the desalination plant was built to deliver. So again, why this has happened? Because when you do the economics, at that point, desalination was cheaper than fixing the leaks. What we now know is that if the water was properly valued, in other words, if the water that was lost in leaks was included in the decision-making as a value lost in the process, the outcome would have been very different. So this shows kind of how by putting value to water as a resource, your decision-making is very different. You don't end up with these very short-term, unsustainable almost solutions that address these issues. So, of course, obviously it was more economical, was it sustainable? Well, they did their best to make it sustainable. So, for example, although the desalination requires much more energy, almost 10 times more energy than the typical drinking water plant, their energy comes from a startup called CHIP, which is located next to the site, and it turns into energy all the fat and blockages, all the fat that comes from the sewers and oil that otherwise would have caused blockages in the sewers. They use that to create energy, and also they put a 64-meter tall wind turbine that produces some of the energy that is required by the plant. However, over the 13 years since its commencement, the plant hasn't really been used because of how expensive it is to operate it. So only 3 times it has been used since 2010. And this is even in the drought of 2022, where we had a lot, when they had the host ban, the house spray ban, they didn't use it because it's so expensive. Not only that, but since 2022, they have started counting how much money they spend on responding to leaks, so going and fixing the leaks when they take place. And that's a huge amount of money. So when you have, when you add that taking that into account, it would have been another option to go further, I think. But currently, the company loses 630, so that has increased since then, 630 million liters per day just in terms of leaks. And it has to reduce it by 20% by the year 2025, as requested by Ofwat. And not only that, it gets even worse. They also had to pay 65 million back to its customers because in 2018, an Ofwat investigation demonstrated that they didn't do enough to deal with the leakage. So overall, a not very sustainable decision, but driven by economics, right? Driven by the fact that at that point, they thought they were doing the clever thing, which was to build a desalination plant, good for, say, for producing something big, and at the same time addressing a problem without really understanding the sustainability implications of this action. Now, is desalination the answer? Even if leakage was not the problem, I think that's one of the questions it was asked by people in preparation of this session. Is desalination the answer? And the answer is, that's part of the problem, mainly because the more water you produce, the more wastewater you produce. So although it helps you with producing more safe water, but at the same time, you need to do something with your wastewater. So maybe that's what takes us to the idea that actually Thames Water has built that plant next to the biggest sewage treatment works in Europe. That's in Beckton, and they could, in theory, be using this desalination plant to treat the wastewater from London to producing safe. They're not even thinking about it, but that would be a solution that would make sense in the future in terms of reusing our effluent and being much more sustainable. Now, but at the same time, I want you to think about how safe is the water you currently drink. So what is in the water we drink? If you think that the water normally is abstracted from a river, it's treated, it is distributed, and then it goes back as wastewater. Many places in England, many cities in the world, actually abstract water further downstream from the discharge point of another wastewater treatment plant, right? So if you look at the water we drink in London, if you can see in these sources of drinking water, it's mainly surface water in London. So most of our water comes from the River Thames and its tributaries in this part of where London is. Whatever we say about Imperial and Oxford, comparing at the end, we do drink out of the water out of the toilets in Oxford because the discharge point from Oxford is further up the abstraction point for London. So in theory, you can see that we do have a case of indirect water use in London. There are 12.5 million people living in the catchment, using, as we said, about 150 liters per day, 352 sewage treatment works in the whole catchment, and there are parts in the summer that some of these tributaries are just effluent from works. The main river is also effluent dominated, so you can see that we like it or not, indirectly have a case of indirect water use in this case. So my question is, so what is in the water you drink? How confident are you that when you know that the water you drink, it comes out of the toilets? What do you think? Well, This is where regulations come. So this is the Drinking Water Directive. The Drinking Water Quality Directive establishes a list of microbial parameters, chemical parameters, and other indicators that define if the water is safe, right? So in other words, they set standards. This is how the, This is for example, the EU Drinking Water Directive prescribes norms for pesticides. You know, pesticides, a lot of them are carcinogens, in terms of water that is intended for human consumption. So they say that any single pesticide needs to be less than 0.1 milligram per liter of water, or for the sum of the pesticides for total pesticides, less than 0.5 milligrams per liter. How do you think this is? How they have decided in Europe that anything below 0.1 milligram per liter is safe, and anything above it, it's not? How, right? Some scientists somewhere said, you know, in order for you, the company has no issues if the levels are below 0.1 microgram per liter, but if it's above, you have to do something to remove them. What do you think is the logic? How did that happen? How do we know that anything below is safe? Yeah? Any ideas? Yeah? No, that wouldn't be allowed. But you could run toxicological studies. You could run tests with other microorganisms. You could look at epidemiological data, right, to find out which is safe. But that's not how they did it. Any other ideas?
They just put their finger in the air.
They didn't put their finger in the air, but very close to that. They said that pesticides, carcinogens in our water, we don't want any. There should be zero. But when you go to a chemist and you say, what is zero? The zero at that point was the limit of detection of the method that you measured for this. So at the point of introduction of the law, the only thing that we could measure as zero was 0.1 micrograms per liter. And that's how the standard was made, right? So it is, in other words, it's a substitute for zero. It doesn't mean that anything, but after so many years, how it's interpreted by companies, by people, is that it's a level of safety, but it's not. It should be zero. Right? So you can see kind of how sometimes regulations are helping, but it's not clear kind of how they impact the actual action that is required. So at the end of the day, the issue comes down to how we trust, I think, governments to keep our drinking water safe. If it's directly recycled or if it's regulated in the way it is now, people need to understand what water comes from, you know, what has been filtered out, you know, what is the technologies we use. And in some cases, you know, we say water should be judged by its quality, not by its history. The main barrier to water use is currently public perception. People think that recycled water is not, it might have some risk, but actually it's cleaner than drinking water, because we know that it's been recycled, and we know that we need to look for things. We know that we have the right processes to make sure that it is cleaner, rather than what happens now, for example, with London, when you don't measure a lot of the things that might be a problem. So the idea is that, is it really a perception of the public, or is it the authority's perception of public perception that is the real barrier? And maybe as people are using more to environmental consents, more to recycling, they'll be willing to accept, you know, drinking toilet water when obviously this could be of much better quality than what they are exposed potentially now. So that's I think this is our last kind of crisis, and it was referred to much earlier in the talks. This is about the sewage effluents, the combined sewer effluents, and this is kind of what's happening, why are they so frequent. And we've done a lot of work with this. We looked at all of this. There are 5,187 water treatment works in the country, in England, 14,346 consented to discharge points of where, how they really work is that the system, all these works have been designed to treat our wastewater plus an amount of rainfall. They should only be operating where there is a lot of rain, so extreme events very infrequently. But because of how the low capacity of this work, because all these systems were designed years ago, they ran out of capacity. So these combined sewer overflows are being used to deal with their capacity. Climate change makes things worse, but at the end of the day, it's the lack of investment in infrastructure. It's the lack of investment in actually building, upgrading renewing, expanding the wastewater treatment works that are needed for the increased demand. And you can easily see that because if you just look at England's population has increased by 6% just in the last 10 years. Currently 56.52 million people live in urban centers, more than what the plans were designed to address. And again, the CSOs are used much more frequently because part of the system are used at and over design capacity. And again, could you say the industry is at fault here? Well, this is one of the most highly regulated industries in the country. The water sector is highly regulated. The infrastructure is very expensive. So you could see it as a way of trying to do their best in terms of keeping the bills low, but at the same time finding ways to address the problem based on efficiencies. And Ofwat also has kind of sits on a thin line between protecting consumers' rights, interests, and at the same time ensuring that the industry has enough funds to upgrade the infrastructure. So this is something that has to do with balancing regulation, and at the same time this idea of how much people are willing to pay for this infrastructure. It's not just in the UK. We have to say that most developed countries are facing the same problem. The Biden administration in the US in 2021 allocated an impressive $111 billion to upgrade the country's infrastructure. Again, significantly less than what the American Water Works Association calculated as what is needed to really bring this country up to standards. So this is a symptom of the developed world who has invested in the past to this infrastructure, but has not kept up with really sustaining and providing these very basic, addressing these very basic needs in terms of water. Again, we have to remember that from pumps to pipes, this infrastructure is often out of sight. And although a very important commodity, people only understand when things go wrong, what it needs. We don't really always recognize the importance of this infrastructure, and this is a problem in terms of how it's funded and how investment is there to address these needs. Environmental regulations, interestingly, have a role to play. So even in the past, most of these regulations came from the European Union. The UK did its best most of the times to avoid fines. So it really implemented them in a way that didn't deliver always the best outcome, but just enough to deal with them or to avoid the fines. And this is something that the industry needs to avoid. The industry needs to move away from just doing enough to avoid paying the fines or just enough to meeting the regulations. They have to do enough to really see the return of the investment in terms of what is the purpose of it, in terms of the benefit you see for the environment, for the public. So it needs to move away from just looking at kind of the role of policy as doing the minimum. It needs to really invest in developing real solutions for taking actually a leading role in delivering sustainable water and infrastructure investment that addresses not just current needs, but also the needs in the future. The whole sector needs to come together and really deliver a collective vision of a future. Most of the time, we address problems. We look at when something happens and we find a solution. What we don't do is kind of envision what is trying to deliver in the long term. So look at the future that we all desire and all we want to achieve and working towards that vision. And that's, even in terms of net zero, doesn't always happen. So just to close, water is very important. It must be protected. It must be equitable and affordable. And water infrastructure enables prosperity. So it needs to be financed, adequately implemented, and sufficiently maintained. And I guess where all of you have a role to play in this exercise. Thank you.